Now we're going to get into the questions, the naming, the place where it all starts to make a bit more sense. Just notice a little error. I've just put a 2 in here. That wasn't there before. That must have been an error. So you had it like that. It should be like that. So carbonate is 2 minus. Anyway, it's in this cheat sheet down here. Here's our cheat sheet. Initially, you're going to have it. I put in 1 extra polyatomic ion, which isn't going to be very common to you, but just kind of test you. There's lots and lots of different polyatomic ions. These are the common ones. And we're going to get straight into the naming. First thing that you ever need to do is realize if something's inorganic or covalent, which in the last video you should have realized that all you have to do is recognize if it's metal or non-metal. So we've got carbon and oxygen as our 2 elements in this first one. And if you see over here, okay, generally this little area, step down here, this is like my border, and anything to the right is a non-metal, with the only exception being hydrogen. Hydrogen is the only non-metal that sits on the left-hand side. So all of this is non-metals, and there's a bit of debate over, all these things down here. So anyway, don't worry about it too much, but I got carbon, non-metal, oxygen, non-metal. I am in the covalent naming world. So first things first, I'm going to put a C there. The other thing that's a dead giveaway is it's a dioxide. So the name has pretty much told me that it's a covalent compound because it uses prefixes like mono, di, tri, and all that kind of stuff. You may notice that there's not a mono there. If there's a mono on the first one, they don't bother putting it. It's called redundant. So you don't ever say monocarbon dioxide, but you do say carbon monoxide. Anyway, for the chemical formula, CO2. I put a 2 because di means 2. Next one, we got aluminium and chlorine. Okay, so first, I've obviously got the advantage. Aluminium is a metal. You should know that. Straight away, I should just be able to go ionic. Okay, chlorine's a non-metal, by the way. It's over in group 7. And name the metal first. In nice aluminium. Non-metal second. Instead of chlorine, I'm going to change it to chloride. And that's done. In this next one, I've got oxygen and fluorine. If I'm not familiar with the periodic table, I got these 2 right here. 2 non-metals, covalent. I got 1 oxygen, so I just get to name it by itself, called oxygen. Remember, I don't say mono-oxygen. And I'm going to say difluoride. Ide again to represent they're chemically bonded. Ide again. Phosphorus pentachloride. You shouldn't even need to go looking. The penta tells me it's covalent. Anyway, they're both non-metals. Phosphorus, a lot of people get these confused with potassium and phosphorus. Potassium's K, phosphorus is P, and chlorine is Cl, and then I have 5 of them. Okay. Coming up to this one, I got sodium phosphate. Here's the first time that you've encountered one of these polyatomic ions. So you've encountered phosphate. So you go sodium. Here's the kind of thing. Well, firstly, you should recognize that if you ever have a metal, you got kind of 2 reasons. If you ever have a metal, it's ionic. If you ever have metal with something else, if you have a polyatomic ion, because it's an ion, it's going to be an ionic compound as well. Its formula is going to be hard here. This is when you start using what these things in red are up. So if it's a group 1, it's going to have a charge. When it's in ion form, it's going to be +1. So sodium is in group 1. Sodium is going to be that. I don't need to write 1. Let's write plus. I go up here and I see PO4 3- for phosphate. And now this is the first time where you go, what's the ratio that the charges come together to be balanced out? And if I have this times 3, from the positives perspective, I'll have 3+, and that will match this 1 3-. So what I'm saying is I need 3 sodium ions. Let's zoom in on that. 3 sodium ions to match the 1 phosphate. All right? And that's all my working out. You never have that. You just get rid of it and pretend you're more competent than you were. Copper hydroxide. Copper is a metal, ionic. hydroxide, polyatomic ion. Copper 1. Copper 1, by the way, Cu for copper, it's over here. Copper. Copper 1 tells me that the Roman numeral told me the charge is +1. And then I go up and I go hydroxide is OH minus. And this is a 1-to-1 ratio. So +1 matches -1. So I'm going to go copper hydroxide. I don't need to do anything fancy. Okay, let me get rid of my working out. Calcium carbonate. Calcium's a metal, ionic. Carbonate's a polyatomic ion. 2 reasons why it's ionic. Calcium. Go find calcium. Calcium's here. Ca2 plus because it's in group 2. Carbonate is up on my cheat sheet. Carbonate is CO3 2 minus. The ratio they come together in terms of charges is 1-to-1. So I just go calcium carbonate. This one's a bit harder. V is vanadium, this guy here. And O is oxygen, so it's a metal and a non-metal, it's ionic. And this one's a bit harder because you've got to kind of do the reverse of what we've been doing. Naming is pretty easy, except for the Roman numerals. So for naming, metal first, vanadium. And I'm going to leave some space for the Roman numerals. And then I go to oxide. And how do I work out? Well, one method to work out is to go, well, I do actually know the charge of oxygen. Oxygen is in group 6. Okay, oxygen's over here in group 6. And every single time, oxygen will have a charge of -2. So I do know that oxygen is going to be 2 minus. And I could set it up like algebra. I could be like the charge of 2 vanadiums plus the charge of 5 oxygens equals 0 overall. There is no overall charge. Okay, and I go, well, 2 vanadiums plus 5 by -2 equals 0. So 2 vanadiums equals 10, and 1 vanadium must equal +5. And then I can go Roman numerals for 5 is V. And the other method that people like to do is a reverse cross and drop. So you take that 5 up from the oxygen, and that's the 5 plus. And you might see a relationship between the 2 and 5 down the bottom, and like cross and drop. So take it up. Now I don't mind that method, but I kind of, again, comes into some errors every now and then. But handy to know for pace. Right. I'm going to go really quick. This is copper, a transition metal. Copper. It's copper sulfate. Should have just left some space for Roman numerals. Sulfate. And I go, well, sulfate's 2 minus up here, 2 minus. And so I need to, copper must be 2 plus if it's going to match the sulfate 2 minus. Okay. Iron is a transition metal. Okay, I got the advantage of knowing all this. Iron is sitting over here. Iron's a transition metal, so I need metal first. I need some Roman numerals, and oxygen is oxide. So I've got iron. I can, again, just do that quick reverse cross and drop. So I could go iron 3 really quickly, right? And so what that means is iron 3 plus and oxygen 2 minus. Okay, in this next one, got sodium. Sodium's not a transition metal, don't need any that. It's a metal, so I know it's ionic compound. I should have kind of accepted that copper and iron are metals. It's got sodium, sulfide, metal first, non-metal second. In this next one, it's the same thing. We've got we've got a metal and a non-metal. So potassium and non-metal. So potassium and nitride. And the reason why I should have done this, sodium plus sulfur 2 minus. Group 1 for potassium, nitrogen's in group 5 over here, so it's going to be -3. 3 minus, right? Clean that up. I'll do one more. Go magnesium nitrate, magnesium. And notice you recognize that there's this NO3. By the way, the reason why you should be able to recognize polyatomic ions, there's 3 capital letters in there.